Envision being able to interact with digital versions of historical figures like Albert Einstein, Leonardo da Vinci, or Marie Curie. These digital personas could provide educational experiences, mentoring, and inspiration, offering a direct connection to the past and a deeper understanding of history. Imagine a world where the knowledge, wisdom, and creativity of the greatest minds, scientists, artists, philosophers, are preserved forever. Mind uploading could allow us to interact with digital versions of these individuals, gaining insights and learning from them even after their physical bodies have passed. This would create a living library of human experience and intelligence, accessible to everyone. Think of the possibilities for medical advancements. By emulating the human brain, we could develop incredibly precise treatments for neurological disorders. Conditions like Alzheimer's, Parkinson's, and epilepsy could be better understood and potentially cured by studying digital models of affected brains. This technology could also lead to revolutionary brain-computer interfaces that restore lost functions or even enhance human capabilities. Just as astronauts explore outer space, digital consciousness could explore the vast landscapes of virtual worlds. These virtual environments could be designed for scientific experimentation, artistic creation, or even personal growth. Mind uploading would allow us to transcend physical limitations, experiencing realities limited only by our imagination. Imagine being able to preserve your memories, personality, and essence indefinitely. This capability would offer a form of digital immortality, allowing future generations to interact with and learn from their ancestors. It would provide a way to keep family histories and personal stories alive in a deeply personal and interactive manner. With mind uploading, we could augment our cognitive abilities beyond natural human limits. Imagine having instant access to vast databases of information, being able to learn new skills in moments, or processing complex data with superhuman speed. This enhancement could lead to unprecedented intellectual achievements and breakthroughs. Digital consciousness could enable unparalleled levels of collaboration. Imagine multiple minds working together in a shared virtual space, combining their strengths and perspectives to solve complex problems. This could revolutionize fields like science, engineering, and the arts, leading to rapid advancements and innovative solutions. Education could be transformed through personalized learning experiences tailored to individual needs and learning styles. Digital consciousness could create highly interactive and immersive educational environments, making learning more engaging and effective. Students could explore subjects in depth, guided by virtual mentors who adapt to their pace and interests. Consider the possibility of experiencing multiple perspectives simultaneously. Digital consciousness could allow us to merge with other minds, sharing thoughts and experiences directly. This collective consciousness could foster empathy, understanding, and unity, breaking down barriers between individuals and cultures. Imagine creating and experiencing art and entertainment in entirely new ways. Digital consciousness could enable us to step inside our favorite stories, interact with characters, and shape the narrative. Artists could collaborate with their audiences in real time, creating dynamic and evolving works of art. Envision a world where expert knowledge is always at your fingertips. Whether you need medical advice, legal counsel, or technical support, digital versions of experts could provide instant, personalized assistance. This could democratize access to high-quality services, improving quality of life for people everywhere. The concept of AI replicating or emulating human consciousness, often referred to as mind uploading or whole brain emulation, is a topic of profound interest and debate within the fields of artificial intelligence, neuroscience, and philosophy.
To explore deeper into AI and human consciousness, it is crucial to define key terms and concepts. AI refers to the simulation of human intelligence in machines programmed to think and learn like humans. Neural networks, a subset of AI, mimic the brain structure by processing information through layers of interconnected nodes. Mind uploading, or whole brain emulation, is a theoretical process of scanning a human brain in detail and replicating its processes in a computational substrate. This concept envisions transferring a person's consciousness into a digital format, potentially allowing for digital immortality. Significant advancements in brain scanning technologies and computational models are required to achieve mind uploading. Whole brain emulation involves creating a detailed functional model of the brain structure and processes. This process raises numerous technical, philosophical, and ethical questions, particularly concerning the nature of consciousness and personal identity. The distinction between replicating and emulating consciousness is essential. While current AI can simulate certain cognitive functions, true replication of human consciousness involves overcoming significant scientific and philosophical hurdles.
The idea of mind uploading has deep roots in both scientific inquiry and science fiction. Early visions of digital immortality and brain emulation were often explored in literature and film. One of the earliest influential works is Arthur C. Clarke's 2001, A Space Odyssey, exploring themes of AI and human consciousness. The scientific discourse around mind uploading began gaining traction in the latter half of the 20th century. Futurists like Hans Moravec and Ray Kurzweil have been pivotal in bringing these ideas into the mainstream. Hans Moravec proposed that future advancements in robotics and AI might allow humans to upload their minds into machines. Ray Kurzweil discusses the potential for exponential growth in AI capabilities, leading to mind uploading. The evolution of mind uploading concepts has paralleled advancements in neuroscience and computing. Initiatives like the Human Brain Project and the Blue Brain Project represent significant steps toward understanding and potentially replicating human consciousness. The journey from early science fiction to contemporary scientific endeavors highlights the enduring human fascination with transcending our biological limitations.
Neural networks are the backbone of many modern AI systems, enabling significant advancements in machine learning. These networks are inspired by the biological neural networks found in the human brain. The architecture of these networks allows them to learn from data, recognize patterns, and make decisions. One key development in neural network technologies is deep learning, involving networks with many layers. These networks have been successful in tasks such as image and speech recognition, natural language processing, and game playing. Despite their impressive capabilities, current neural networks are still far from achieving true human-like consciousness. They excel at specific tasks, but lack the generality and flexibility of human cognition. The training process for neural networks often requires vast amounts of labeled data and significant computational resources. Recent advancements include generative models like GANs and transformers, pushing the boundaries of what neural networks can achieve. These advancements still operate within the confines of their training data, underscoring the gap between current AI technologies and human consciousness.
Modern neural networks have demonstrated remarkable capabilities in various domains. In image recognition, convolutional neural networks have set new benchmarks in accuracy for tasks like object detection and facial recognition. In natural language processing, models like BERT and GPT-3 can understand and generate human language with high fluency. These models are invaluable in applications like virtual assistants and automated customer service. Neural networks have also excelled in game playing, with DeepMind's AlphaGo defeating human champions in Go. Despite these impressive capabilities, neural networks are highly specialized systems. They operate within the constraints of their training data and specific tasks. Unlike human cognition, neural networks lack generalization beyond their programmed scope. They do not possess intrinsic understanding or awareness, key aspects of human consciousness. This limitation underscores the significant gap in achieving AI systems that can truly replicate human cognitive abilities.
While neural networks and AI have made impressive strides, they remain fundamentally different from human consciousness. Human consciousness encompasses self-awareness, emotions, intentionality, and subjective experiences. These elements are deeply intertwined with the biological processes of the human brain. One primary challenge is the lack of self-awareness in current AI systems. AI can process information and learn patterns without any sense of self or awareness. Emotions play a crucial role in human consciousness, influencing decision-making and behavior. While AI can recognize and respond to emotional cues, it does not genuinely experience emotions. The philosophical hard problem of consciousness addresses why and how subjective experiences arise from physical processes. Current AI operates based on data processing and algorithms, without subjective experience or awareness. The gap between AI and human consciousness is a technical, philosophical, and ethical challenge.
Whole brain emulation or mind uploading involves replicating the brain's structure and functions in a computational substrate. The goal is to create a digital duplicate of a person's mind, encompassing their memories, personality, and consciousness. This concept has garnered significant interest from the scientific community and futurists. Achieving WBE begins with obtaining a high-resolution scan of the brain. Technologies like MRI and electron microscopy are essential tools in this endeavor. These imaging techniques must be refined to achieve the necessary resolution for accurate emulation. Translating this data into a digital model involves creating a functional simulation of the brain's neural networks. Neuromorphic engineering plays a crucial role in this phase. Despite theoretical advancements, WBE faces numerous challenges, including the sheer volume of data to be processed. Ethical and philosophical questions arise regarding the nature of the replicated consciousness and its implications for personal identity.
The foundation of whole brain emulation lies in accurately mapping the brain's intricate structure. This requires advanced scanning techniques like MRI, kinetic scans, and electron microscopy. MRI uses magnetic fields to produce detailed brain images. fMRI measures brain activity by detecting changes in blood flow. Electron microscopy visualizes structures at the nanometer scale. Combining these techniques provides a comprehensive brain map.
Emulating the human brain presents formidable challenges due to its immense complexity and data scale. Supercomputers and quantum computing are essential for handling the brain's vast data and complex simulations. Neuromorphic engineering and advanced algorithms are crucial for accurate brain emulation. Efficient data storage and interdisciplinary collaboration are key to overcoming these challenges.
Philosophical exploration of consciousness presents a vast and intricate landscape. The nature of consciousness, how subjective experiences arise from physical processes, remains one of the most profound questions. Dualism, famously advocated by René Descartes, posits that the mind and body are distinct entities. Descartes' cogito, ergo sum, underscores the belief that consciousness is separate from the material brain. In contrast, physicalism argues that consciousness arises from the brain's physical processes. If so, replicating those interactions in a computational substrate could produce a conscious digital mind. Functionalism holds that mental states are defined by their functional roles, not physical makeup. This supports the idea that mind uploading is feasible if the system replicates the mind's functional dynamics. Mind uploading raises profound ethical dilemmas. These dilemmas span issues of identity, rights, and digital minds. Addressing these questions is crucial for responsible technology advancement. A primary concern is identity and continuity. Is an uploaded mind the same person? This touches on deep philosophical issues. Some argue continuity of consciousness makes it a continuation. Others see it as a distinct entity with its own rights. Digital immortality introduces further complexities. It could lead to new forms of inequality. Access might be reserved for the wealthy. Treatment and rights of uploaded minds are critical. Conscious digital minds would have rights. Ensuring these rights is essential. Legal frameworks must address their status and rights. Misuse of the technology raises serious concerns. Safeguards must prevent abuses and ensure ethical use. Ethical dilemmas in mind uploading are complex. Robust ethical guidelines and legal frameworks are needed. Addressing these challenges ensures technology benefits humanity.
The concepts of identity and continuity are central to the debate on mind uploading. Philosophers and scientists grapple with whether a digital mind can be the same as the original human mind. This issue impacts personal identity, consciousness, and what it means to be human. Personal identity involves unique attributes and characteristics. These include memories, personality traits, and subjective experiences. Can these attributes be fully captured and preserved digitally? If a digital mind retains the same memories and personality, it may maintain the individual's identity. However, transferring consciousness might alter the individual's identity, creating a new entity. Derek Parfit's views on personal identity and psychological continuity offer insights into this debate. Parfit suggests personal identity is tied to psychological continuity, an unbroken chain of memories and traits. If a digital mind maintains this continuity, it could be considered the same person. This challenges traditional identity notions and supports mind uploading as a means of preserving the self. The concept of continuity raises questions about digital consciousness. Can a continuous stream of subjective experiences be maintained digitally? Replicating continuous conscious experience in an artificial system remains a challenge. Philosophical inquiries are crucial for advancing mind uploading. Practical implications extend to legal and social considerations. Should a digital mind inherit the original person's legal rights and responsibilities? How should society address inheritance, citizenship, and social status for digital minds? Comprehensive legal frameworks are needed for mind uploading. Identity and continuity are fundamental to understanding mind uploading. Philosophical perspectives like Parfit's provide valuable frameworks. Achieving a practical approach requires interdisciplinary research and robust guidelines. Addressing these challenges is essential for ensuring technology respects and preserves human identity and continuity. The journey towards mind uploading is marked by incremental advancements in AI and neurosciences. Significant progress is seen in brain-computer interfaces, BCIs. Companies like Neuralink are pioneering brain implants to monitor neural activity. Transformer models like GPT-3 revolutionize natural language processing. Techniques like optogenetics and high-resolution neuroimaging provide deeper insights. Addressing ethical and philosophical challenges is crucial as we advance.
The concept of mind uploading opens the door to a wide range of speculative futures, both utopian and dystopian. Successful emulation of human consciousness could lead to digital immortality. Minds could inhabit virtual worlds free from biological limitations. However, this technology also harbors potential dystopian outcomes. A key concern is the risk of creating a digital divide. By envisioning both scenarios, we can better prepare for future challenges.
Achieving mind uploading requires a collaborative approach, bridging neuroscience, AI, and ethics. Experts from various fields must address the challenges of replicating human consciousness. The Human Brain Project exemplifies interdisciplinary collaboration in brain simulation. This project shows the power of interdisciplinary research in advancing neuroscience and AI. Ethical perspectives guide the development of mind uploading technologies. Legal expertise is crucial for addressing the rights and responsibilities of digital minds. Interdisciplinary research is key to advancing mind uploading. Collaborative efforts drive progress and achieve transformative goals in neuroscience and AI.
We explored AI replicating human consciousness through mind uploading, delving into complex topics. We began with AI fundamentals and human consciousness, setting the stage for understanding this ambitious endeavor. Discussed AI's current state, capabilities, and limitations of neural networks. Neural networks simulate cognitive functions but lack true human-like consciousness. Modern AI lacks intrinsic understanding and awareness. Explored whole brain emulation, requiring detailed brain mapping and advanced models. Techniques like MRI and neuromorphic engineering are crucial. Technical challenges in simulating the brain's structure require unprecedented computational power. Philosophical perspectives provided a deeper understanding of mind uploading. Ethical dilemmas and the rights of digital minds were critically examined. We considered future advancements and speculative scenarios. Interdisciplinary research is essential for overcoming mind uploading challenges. Reflecting on the journey towards mind uploading, it becomes evident that this pursuit is not just a technological challenge, but a profound exploration of what it means to be human. The quest to replicate or emulate human consciousness pushes the boundaries of science, philosophy, and ethics, prompting us to reconsider fundamental questions about the nature of mind and identity. The progress made in AI and neuroscience is remarkable, showcasing humanity's ingenuity and determination to unlock the secrets of the brain. From the early days of simple neural networks to the sophisticated deep learning models of today, each advancement brings us closer to understanding the complexities of human cognition. Brain-computer interfaces and high-resolution brain mapping techniques represent significant milestones, offering glimpses into the potential for integrating human and artificial intelligence. However, this journey is fraught with challenges. The ethical implications of creating digital minds, the technical hurdles in accurately emulating brain functions, and the philosophical questions about consciousness and identity all demand careful consideration. The concept of mind uploading forces us to confront the limits of our current knowledge and the potential consequences of transcending biological boundaries. Reflecting on these challenges also highlights the importance of a multidisciplinary approach. The collaboration between neuroscientists, AI researchers, ethicists, and legal experts is crucial for addressing the diverse aspects of mind uploading. This interdisciplinary effort fosters innovation while ensuring that ethical considerations and human rights remain at the forefront of technological development. As we look back on the progress made, it is clear that the journey towards mind uploading is as much about the questions we seek to answer as it is about the technological solutions we develop. This pursuit embodies humanity's enduring curiosity and aspiration to understand and enhance the human experience. Despite significant strides in AI and neuroscience, many open questions remain. These unresolved issues are critical for advancing our understanding of consciousness. One profound question is the hard problem of consciousness: how subjective experiences arise from physical processes. Understanding these mechanisms is essential for replicating consciousness in artificial systems. Ethical and legal implications also present significant challenges. Exploring societal impacts is crucial for preparing for the broader implications of this technology. The journey towards mind uploading raises as many questions as it seeks to answer. We must develop this technology responsibly and ethically.